In this video, we're going to find the distance between 2 square roots of 3 square root of 5 and negative 3 square roots of 3 negative 4 square roots of 5. So the first thing you may notice about this is these points are not nice clean points like some of the previous examples we've done, like 1, 2, 3, 7 or something like that. They involve radicals, and then really they involve irrational numbers. But as you'll find, we're still going to go through the exact same process. We're still just going to label this first point x1, y1, and label the second point x2, y2, because they're still just x and y values, and we have our first and our second point. Again, it doesn't matter which one you call the first and second point, just be sure you keep your 1's together and your 2's together. So after you label them, we're going to plug those values into the place of these variables in our distance formula that you see written in blue. So the distance, lowercase d, is going to be equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And so just like we would do with an easier example, quote unquote, what we're going to do is we're just going to put these numbers where they go in the formula. So our distance in this case is going to be, in the place of x2, we're going to put negative 3 square roots of 3. So minus 3 square roots of 3 minus x1, which is 2 square roots of 3. And that's going to be squared. Plus, and instead of y2 minus y1, we're going to have negative 4 square roots of 5 minus the square root of 5, because those are our values for y2 and y1, squared. And so now you can see that it's really not too bad, because in each of these slots, or in each set of parentheses, we have things that are going to simplify nicely because we have like terms. So we have negative 3 square roots of 3 minus 2 more square roots of 3. That means we're going to have negative 5 square roots of 3. Now you want to be sure you keep that in parentheses, because when we apply that squared to each of those numbers, we have to do it to each one, not just to one of them. So don't forget about that. Same thing's going to happen with our second term. We have negative 4 square roots of 5 minus 1 more. That's going to give us negative 5 square roots of 5. And again, be sure you put that in parentheses. And so now we're going to apply our properties of exponents that we talked about a long time ago. We're going to apply this second power to each of these numbers right here in each case. So essentially we're going to say negative 5 squared is going to be 25. And that's going to be multiplied by the square root of 3 squared, which is just 3. And then for our second number, again, we'll have negative 5 squared, which is going to give us 25. And that's going to be multiplied by the square root of 5 squared, which gives us 5. And now just continue simplifying where we can. 25 times 3 is going to give us 75 for our first term under the radical. 25 times 5 is going to give us 125. And then we can combine those two terms to give us the square root of 200. Now at this point, that's definitely the right answer, but it may not be the most simple answer, or the answer in the simplest form. So you want to go and check and make sure that you can't break 200 into factors, one of which is a perfect square. And so let's bring our work right up here, and let's think about 200. So some factors of 200 are 1 and 200, 2 and 100, 4 times 50. So instantaneously you think, okay, well 4 is a perfect square. We can take the square root of that. So we're going to change the square root of 200 into the square root of 4 multiplied by the square root of 50, because 4 times 50 gives us 200. And now we're going to simplify, again using our properties of square roots. We're just going to say the square root of 4 is going to give us a 2 times the square root of 50. So we used our properties of square roots to break that into factors, because if you have two numbers multiplied under one radical, you can break that into two radicals where you multiply those factors together. So now let's look at our answer again. We've broken it down to 2 times the square root of 50, and let's ask ourselves, can we break 50 into any kind of perfect square? Well, yes, we can. That's going to be 2 times 25. And so 50 can be written as 25 times 2. So 2 times the square root of 25 times the square root of 2, which will give us 2 times 5, because the square root of 25 is 5, times the square root of 2, which gives us 10 square roots of 2. And that's going to be our most simple answer. Now, when you started simplifying the square root of 200, if you said that was the same thing as 100 times 2, that would be fine. It would have saved some steps. But I just wanted to show you that you could break it up into factors multiple times, and you'll still get the right answer.